Create a 10 minutes video for YouTube about Quantum Supremacy 2.0. China claims world's fastest quantum computer. Imagine waking up to a world where traditional computers, the ones that power your phone, your laptop, even the world's biggest data centers, suddenly feel obsolete. A world where calculations that would take your most powerful supercomputer thousands of years are solved in seconds. This isn't science fiction anymore. It's happening again. China has just claimed what they're calling Quantum Supremacy 2.0, the creation of the world's fastest quantum computer. And this time the world is watching very closely. But before we dive into what China has actually achieved, let's rewind a bit. Remember a few months ago during the global tech shutdown, the one that sent ripples across the internet, halted research collaborations, and froze half the digital world's biggest projects? That event wasn't just an accident. It was a domino effect triggered by one of the biggest infrastructural resets the modern internet has ever seen. Let's unpack that for a moment. A shutdown, in this context, refers to a sudden, widespread halt in critical digital operations, data centers going offline, cloud servers failing, or global networks temporarily disconnected. Sometimes it's caused by cyber attacks, sometimes by policy disputes, and sometimes by massive system updates gone wrong. The last one? It was a perfect storm of all three. It began when several key nations started implementing stricter controls on semiconductor exports, especially those related to quantum computing and AI chips. The United States had imposed new restrictions, the EU followed suit, and China responded with its own countermeasures. At first, it looked like another round of the tech Cold War. But then, when several major data routing hubs in Asia went offline simultaneously, blamed on maintenance updates, the ripple effects were catastrophic. Servers crashed, financial systems stalled, AI models went dark, and collaborative networks like research grids between universities froze. It was one of those moments when humanity realized how fragile our hyper-connected digital infrastructure truly is. And in the midst of all this chaos, China quietly dropped a bombshell. The unveiling of Jiuzhang 3.0, its next-generation quantum computer, claiming to have achieved what they call quantum supremacy once again, this time decisively. Now, if you're thinking, wait, didn't Google already claim that title back in 2019? You're right. Google's 53-qubit Sycamore processor performed a specific quantum task exponentially faster than any classical computer could. It was hailed as the dawn of the quantum era, but it was also just one very narrow proof-of-concept experiment, an early taste of what might come. Then, in 2021, China's University of Science and Technology in Hefei unveiled Jiuzhang 2.0, which used photons, particles of light, instead of superconducting circuits. It performed calculations 100 trillion times faster than classical supercomputers could handle. The scientific community took notice, and now Jiuzhang 3.0 has raised the bar once again. So what's so special about it? According to Chinese researchers, this machine performs a type of computation called Gaussian boson sampling, using 255 photons. That may sound like technobabble, but here's what it means in simpler terms. It's solving an insanely complex mathematical problem that no classical computer on Earth could feasibly touch, not even if you gave it billions of years. To put it in perspective, if a traditional supercomputer tried to replicate Jiuzhang 3.0's latest test run, it would take longer than the current age of the universe. Jiuzhang 3.0 does it in less than a second. But this isn't just a race for bragging rights. Quantum supremacy, when a quantum computer outperforms a classical one in a specific task, has deep implications. It could redefine cryptography, revolutionize chemistry and material science, accelerate drug discovery, and even simulate entire economies. And that's where the political and technological tension deepens. The last shutdown didn't just reveal our dependency on digital systems, it exposed our vulnerability in global technology supply chains. Quantum computing, like AI, is now becoming a matter of national security. Whoever leads in quantum technology could, in theory, decrypt encrypted communications, optimize logistics on a national scale, or develop breakthroughs in nuclear fusion or military AI. So when China claims Quantum Supremacy 2.0, it's not just a scientific milestone, it's a geopolitical statement. The details coming out of China are fascinating. Reports suggest that Jiuzhang 3.0's architecture is more stable and scalable than its predecessors. The team has apparently managed to reduce photon noise, increase coherence time, and design new error correction techniques, all major hurdles in the quantum world. And this progress didn't happen in isolation. Despite the tech lockdowns and restricted data flow, Chinese labs have been building their own quantum ecosystems, fabrication facilities, photonic chip foundries, and in-house algorithms. In a way, the shutdown acted as a catalyst, forcing self-reliance and rapid innovation. Meanwhile, in the West, quantum projects like IBM's Condor and Google's next-generation Sycamore 2 are still in progress, but none have yet demonstrated a computation of this scale publicly. And this is where things get interesting. China's claim hasn't yet been independently verified by the global scientific community. The data, as usual, is tightly controlled. Some experts believe the quantum supremacy label might be more political than technical, a way to assert dominance in the ongoing tech arms race. Others argue that, even if exaggerated, it still represents genuine massive progress. Either way, it's clear that the pace of quantum innovation is accelerating faster than most governments can regulate or even comprehend. But let's pause and talk about what this all really means for us. Quantum computers aren't just faster machines, they're fundamentally different. Instead of bits, which represent zeros or ones, quantum bits, or qubits, can exist in multiple states at once, thanks to a property called superposition. They can also become entangled, allowing complex calculations to be performed in parallel. Imagine not checking one possible answer at a time, but all possible answers simultaneously. That's the quantum advantage. But it's also why they're so hard to build. Qubits are fragile, they decohere or lose their quantum state within fractions of a second. That's why controlling even a few hundred qubits stably is considered a major scientific feat. So when China says Jiuzhang 3.0 is operating with 255 photons in a stable system, it's a sign they've made serious breakthroughs in precision engineering and quantum optics. The implications are staggering. If these machines become scalable and accessible, they could make classical encryption obsolete, break today's internet security protocols, and force us to reinvent digital privacy from scratch. Entire industries, banking, cybersecurity, pharmaceuticals, would have to rebuild their foundations. And this brings us full circle to the shutdown. That global digital freeze was more than an infrastructure failure. It was a warning, a glimpse of what happens when humanity's technological systems evolve faster than our ability to secure or govern them. Quantum computing could magnify that risk 1,000-fold. Imagine a future where only a handful of nations or corporations control machines that can crack any code, predict complex systems, or simulate entire biological networks. The balance of power, both political and economic, would shift overnight. That's why every major power, from the US to India to the EU, is racing to establish quantum infrastructure, quantum encryption standards, and even quantum internet networks. So when China announces Quantum Supremacy 2.0, it's not just a scientific milestone, it's a declaration of intent. It's saying, we're ready for the next era of computation. And the question the world now faces is, are we? Because quantum computing isn't about faster search engines or better smartphones. It's about rewriting the rules of what's computationally possible, reshaping industries, economies, and even the meaning of digital truth itself. As we move forward, the challenge won't just be building faster quantum machines, it'll be deciding what we do with them and who gets to decide. So next time you hear about a shutdown or a quantum breakthrough, remember, they're not isolated events. They're the tremors of a deeper shift, one that's taking us beyond binary logic, into a new era where the future itself might just be entangled.